Solve the following systems of equations using elimination. So, using elimination, that means we want to eliminate either x or y. So, I'm going to rewrite the equations here. That way we can see them clearly. And to be able to highlight which variable makes the most sense to eliminate. So, if I wanted to eliminate the y's, I would multiply either, the numerator and denominator by the coefficient of the coefficient of y for the other expression, and for the other equation. So here I would multiply the bottom equation by 3 and the top equation by 2, and one of them would have to be negative. That way we would have 6y and negative 6y. So I would have to manipulate both equations here in order to eliminate y. However, in order to eliminate x, we would only need to manipulate one equation. Since x is already having one positive and one negative, we don't need to change them to have one being positive and one being negative. And since the first equation has a coefficient of 2 and the second equation has a coefficient of negative 4 in front of x, 4 is a multiple of 2. So we can multiply just this whole first equation by 2, and that would give us 4x to eliminate. So we want to distribute that 2 to all the terms, including both sides of the equal sign. And that way everything is held equal on the left and on the right. So really, I would probably want to notate it like this. 2 to both sides and 2 to this side. So 2 times 2x is 4x, and 2 times 3y is 6y, and 12 times 2 is 24. And then I'm going to write my original equation below it. 4x plus 2y is equal to 8, and nothing has changed. And we'll see here by multiplying the first equation by 2, this leaves us with 4x and negative 4x, which means that these terms can cancel each other out when we add them together. And then 6y plus 2y gives us 8y, and 24 plus 8 gives us 32. And now we want to solve for y. So we're going to divide both sides by 8. And when we divide both sides by 8, we're left with y is equal to 4. Now I'm going to want to use this to solve for x. So I could pick any equation that I have in order to do this. So I'm just going to pick this first equation. I could have picked the second equation. And I'm going to move it over and substitute in y. So we have 2x plus 3y is equal to 12. And here we'll see that we're going to substitute in y for here. So we're going to get 2x plus 3, and what we're substituting in for y is the number 4, because y is equal to 4, and that will all be equal to 12. So we have 2x plus 12 is equal to 12. And we're going to subtract 12 from both sides using inverse operations, and 12 minus 12 actually gives us 0. So here we're left with 2x is equal to 0. Then we can divide by 2 on both sides. These 2's will cancel out, and we're left with x is equal to 0, because 0 divided by 2 is 0. So my final answer can be written in the form 0, 2. Now, a lot of people panic when they see that x is equal to 0, but that's perfectly acceptable. In a coordinate point, it's just the point 0, in a coordinate grid, it's the point 0, 2. So our point is on the y-axis. If we wanted to check the solution, though, to see if our answer is correct, if we wanted to check, we can just plug it into one of the equations and see if it holds true. So we can plug it into 2x plus 3y is equal to 12. For x, we're going to plug in 0. And for y, we're going to plug in 2. So we get 0 plus, y isn't equal to 2. Why did I say that? Y is equal to 4. I'm sorry, everyone. 0, 4. Here, the answer was 4. Whoops. Okay, so 3 times 4. 3 times 4 is 12, and we get that 12 is equal to 12. I knew I was wrong because here I was going to get 6 is equal to 12. But I knew that that was the correct answer. So we see that our solution of 0, 4 holds true, not 0, 2, 0, 4.